So let's have a continuation about buoyancy. So again, what is buoyancy? Means to say that it is the ability to float. Okay? So this also relies with the principles of Archimedes, also known as Archimedes principle. We know already what Archimedes principle is, in which, based on the history about this famous chemist, famous physicist and mathematician, okay, known as Archimedes. More than 2,000 years ago, a Greek scientist named Archimedes created a law about buoyancy. He used to observe actual, that's why his expression known as Eureka, I found it, created loud noise when it comes to physics and mathematics, when it comes to buoyancy. According to Archimedes' principle, he stated that the buoyant force on an object, right, in a fluid is equal to the weight of the displaced fluid. Okay? What does that mean? From the original amount of water present, by the time the object's body weight takes place, it will eventually change and increase the level. And that increase is already a displaced fluid due to buoyancy, due to buoyant force. Suppose a block displays 250 ml of water, with 250 ml of water weight about 2.5 Newton. So, what can we say about this? According to the principles of Archimedes, the buoyant force keeps pushing upward to let the object float. Do you guys understand? Right? Then, on the block which is 2.5 Newton. So based in this component, guys, that I have shown here, now, Archimedes' principle states, again, that the buoyant force is equal to the weight of the fluid the object displaces. In 1 cubic centimeter of steel weighs more than 1 cubic centimeter of water it displaces. So it sinks. 1 cubic centimeter of ice weighs less, and so it's pushed up. Now let's go back to this diagram. The buoyant force exerted on ice, buoyant force exerted on aluminum object, and the buoyant force exerted on the steel. Now the question there, is their buoyant force the same? Yes or no? Now, we shall check about its density. According to the Newton's third law of motion, an object can push back with no more force than it can push. Okay? So, only thing there that you have to remember is it depends on the amount of fluid or water component. And of course, it also depends about the weight of an object. Alright? That is why object can float, object will sink, or partially or fully submerged. Alright? So say for example, the density of ice in here is 0.92 gram per cubic centimeter. Then, with aluminum with 2.7 grams per cubic centimeters. And then, the density of steel, 7.8 grams per cubic centimeters. So to continue, what causes buoyant force? Always remember, instill this in your mind. It's because it's also present during your midterm test. What causes buoyant force? Buoyant force is what? Upward or downward force? Upward force. When we talk about gravitational force, upward or downward force? Okay, downward force. Threefold forces. Okay? Due to gravity of an object without any control of any external forces. So, buoyant force is the upward force exerted from the fluid component of an object exerted by the surrounding fluid. When an object pushes water, the water pushes back with as much as force as it can. If the water can push back as hard, what does that mean? The indicator there, the object floats like gold, the ship, floating paper or floating leaves. If not, it will sink like steel due to its density of an object. So either, in this scenario, either the object will float, sink, or partially submerge. No? It's because it depends on the weight of an object as well. Right? So, why the object sinks or float? One reason. If the upward buoyant force is less than the object's weight, the net force on the object is downward. Then the object accelerates downward because of the unbalanced forces between the object and the fluid. Okay? So therefore, as you can see, pressure in a fluid, liquids and gases are fluids with material that can flow and have no definite shape. So water and air are both fluids. When we talk about fluid, it's not only liquid. It means to say gas as well. Water and gas is part of fluid. So it's not only about water. You understand? So objects in a fluid experience an upward buoyant force which can make them float. Okay? So therefore, when you push a ball on the water, okay? So we know already that this one, if there were no external forces holding on this ball or controlling on this ball, okay, possible this ball will float, right? But if there were external force, if you want to push that one, okay, under the water, right? Downward force exerted in a ball due to your force of your hand. You try to immerse the ball in the water. Afterwards, what will happen? You might also feel the pressure or the upward force exerted. From where? From the fluid or from the water. Okay? So this is one thing also that we can observe in real life situation. Alright? Now, so therefore, buoyant force is always equal to the weight of displaced water. When the object is submerged in water, it displaces an amount of water that weighs 3 pounds, for example. Therefore, the buoyant force pushing up an object, of course, that will be 3 pounds. So, what is displacement? Now, take note with the word displacement. Water that is being displaced, or displaced fluid. What is meant by the word displacement? Displaced means push away. Push away. The amount of water displaced by an object tells you the volume of that object. The weight of the displaced water is buoyant force acting on an object. Do you understand? So, this is mainly the factor that affects the buoyant force. When can we say that it's positive, negative, and neutral buoyancy? Now, again, let's analyze this. When we say negative buoyancy, FB, not Facebook, buoyant force is, the buoyant force is lesser than, the buoyant force is lesser than gravitational force. Do you understand? So, negative buoyancy means to say, in other words, ability to sink or float. Sink. Understand? So, ability to sink. So, when we talk about negative buoyancy, when an object sinks, means to say that the buoyant force is lesser than the weight of an object. Okay? When can we say that it is positive buoyancy? When we talk about positive buoyancy, in other words, ability to float. Okay, very good. So it's ability to float means to say that the buoyant force is less or greater than. The buoyant force is greater than the gravitational force of an object or the object's weight. So that's the time. This indicates that the object will float, okay, due to its positive buoyancy. What does it mean again? That the object weight is greater than, the object weights, the buoyant force is greater than the weight of an object, okay? So, next, we'll move to neutral buoyancy. So what does that mean? Neutral buoyancy. When we talk about neutral buoyancy, it means to say that the buoyant force is equal to the gravitational force or the weight of an object. So it's the same. So what will happen to the object if it's neutrally buoyant? What do you think will happen if it's neutrally buoyant? It will float. It sinks. What do you think? So, it's not 100% sinking, not 100% floating. So, the possibility would be, if it's neutrally buoyant, okay, due to its object weights and, of course, equal to the buoyant force exerted. So, you will see it's partially submerged. Partially submerged. Alright? So that's how the neutral buoyancy takes place, in which buoyant force is equal to the gravitational force of an object or the object's weight. So take note, we in three important components in buoyant forces. Okay? We have positive buoyancy, negative buoyancy, and neutral buoyancy. Okay? When we say negative buoyancy, the ability to sink, in which the buoyant force is greater than lesser than the gravitational force of an object. When we talk about positive buoyancy, ability to float, in which the buoyant force is greater than the gravitational force of an object or object's weight. When we talk about neutral buoyancy, the gravitational force or